Good morning, everybody. We are looking at day 6 here for intermediate algebra. We left off last class. We were talking about writing equations from words and then solving to find the numbers that were being indicated. We started with basically some pretty straightforward direct translation problems like 4 times a number increased by 9 is 45. Find the number. Well, we just write the equation. Now, I always like to find the equal sign. In this case here, is 45 is equals 45 is what that's saying. So I've already got the part after the equal sign. Now let's do the part before. 4 times the number increased by 9 is simply 4. Depending on what MyMathLab might tell you what variable to use, we're going to just use x. So 4 times x is 4 times the number. Increased by 9 is plus 9. And then we solve the equation. From what we saw yesterday, you guys are pretty good at this. You just subtract the 9. 4x equals 36. And we divide by the 4 to get rid of the 4. X equals 9. Then we have to make sure that we've answered the question. It's asking us to find the number. We did. We found that x equals 9. Other problems might include 2 unknowns, but since we only know how to use one variable, we have to figure out how to express both of those with that single variable. So we might have an answer like 2 consecutive odd integers add up to 58. Find the integers. Here we've got 2 things. We've got a smaller integer and a larger integer. Integer just means that it is not a fraction or decimal. An integer could be positive or negative, but no fraction or decimal portion. So I'm going to let the smaller one be x. The larger one, now if you recall yesterday when we said just simply 2 consecutive integers, it was x and x plus 1. But here it's 2 consecutive odd integers. So that would be like 5 and 7 or 11 and 13. So the second one has to be 2 larger for them both to be odd. So we've got x and x plus 2. They add up, which means we add them together. X plus 2 adds up to means equals 58. Now to solve this, x plus 2, we're just combining the like terms. X plus x is 2x plus 2 equals 58. And now we'll solve it. We'll subtract the 2. 2x equals 56. And we divide by 2. X equals 28. Well, that didn't work out well at all. That didn't come out to be odd integers. I should have said even integers. I miswrote that. 2 consecutive even integers add up to be 58. So x is 28. Now we have to answer the question yet. Find the integers. X is 28. That's the smaller one. We need to find the larger one. So if x is 28, the larger one being x plus 2 is 28 plus 2, which makes it 30. And those do add up to 58. So again, 2 consecutive even integers add up to 58. Find the integers. We ended up with the 2 numbers, 28 and 30. Well, let's take the next step then into something a little bit more challenging, less defined, less straightforward, but it still involves formulas that we're used to. One formula that we're used to is the perimeter of a rectangle. If you recall, perimeter is found by just adding up the sides of a rectangle. I label a rectangle here as that's a length, so this is also the length. That's a width, and that's a width. The perimeter be length plus length plus width. Just add up the sides all the way around. Now we can organize that, shorten it up a little bit by saying 2 times the length plus 2 times the width. And that's the formula we'll typically work, the form that we'll typically use to work on it with. So we might have a word problem like the length of a rectangle is 7 more than its width. The perimeter is 134 inches. Find the length and width. Well, since this is geometric, it's visual for me. I like to sketch out a little picture. We're going to get our length and our width. We can't use both variables. We can't use both a length and a width in our formula. So we know the perimeter, we know 134 inches, that's going to go in for P. But we need to either have the number for either L or W, or we need to be able to rewrite it so that it's in terms of the other one. So we look in our problem, is there one of those, the length or the width, that's referenced to the other one? We see here the length is 7 more than the width. So what that means is if we know the width, the length can be found by taking that width and adding 7 to it. So what that means is over in this formula over here, we're going to replace length with width plus 7. So that formula becomes the perimeter. We put in 134 for the perimeter equals 2 times, instead of L for length, we're going to put in W plus 7 because the length equals width plus 7. And we still got to do plus 2W. Notice that this formula here, we just replaced P with 134 because that is the perimeter, and we replaced L with the W plus 7. Everything else stayed the same. Now we can start to solve that equation. So on the left side, there's nothing to do. On the right side, we have to combine. We see the parentheses. We'll multiply by the 2. 2 times W is 2W. 2 times 7 is a positive 14. And we still have this 2W on the end yet. There is still more we can combine on the right side. So we keep the 134. We got 2W and 2W is 4W. And we still have the plus 14. Now we can go ahead and start to solve that. Subtract 14. 120 equals 4W. Now we divide by 4 to get W by itself. So after we divide, we get 30 equals W. So 30, not 3. Now again, we have to make sure we go back and answer the question. The question told us to find the length and width. We found W is 30. That would actually be inches, would be that unit. The length is W plus 7. That's going to become 30 plus 7, which is 37 inches. So now we've answered the question. The width is 30 inches. The length is 37 inches. And there are, of course, different variants of that formula. You might have the length of a rectangle is 4 times the width. The perimeter is 180 feet. Find the length and width. So again, I'm going to draw out my little rectangle. I have a width and I have a length. And again, I am given my length in terms of the width. The length is 4 times the width. So L could be equal to 4W. My formula is still perimeter is 2L plus 2W. And I'm going to substitute into that. First of all, I'm going to replace P with 180 feet, or just 180, because that is the perimeter. 2L, well, I'm going to replace L with 4W. So instead of 2L, it would be 2 times 4W. And then I still have the 2W here. So again, all I did is I replaced P with 180, and I replaced L with 4W. The rest of the formula stayed the same. And now we can solve. So nothing happens on the left side yet. We have 2 times 4W is 8W. There's still more we can combine on the right side. 8W and 2W is 10W. And now we'll solve for W. Divide by 10. 18 equals W. Again, let's go back and answer the question. We were asked to find the length and the width. 18, that would be feet because the perimeter was in feet. 18 feet is our width. Our length is 4 times W, or 4 times 18, which is going to be 72 feet is our length. So we've got a width of 18 and a length of 72. We have other geometric applications. I shall put it out in words. The measure of an angle is 3 more than 5 times the number it is supplementary there we go, supplementary to an angle whose measure is 6 times the number increased by 12. Find each angle. Well, if they are supplementary, what that means is they add up to a straight line. One is 3 more than 5 times an angle. So we're adding 3 to something, and it's 5x that we're adding 3 to. The other one, it's supplementary. That's our keyword. That's how we know it adds up to a straight line. It is 6 times the number increased by 12. Well, that's just 6x plus 12. The relationship between these is not equals to. They add up to supplements to 180 degrees. So 6x plus 12 plus 5x plus 3 equals 180. So our first step is going to be to add these algebraic numbers, 6x plus 12 and 5x plus 3. Yeah, 6x and 5x is 11x. 12 and 3 is 15. Adds up to 180. And now we'll solve that equation. So we'll subtract the 15. 11x equals 165. And we'll divide by the 11 to get x by itself. X equals 15. Now we have to go back and find the angles. It said find each angle. So this is 6x plus 12. That'll be 6. X is 15. So 6 times 15 plus 12. 6 times 15 is 90. Plus 12 is 102 degrees. Over here, this is 5x plus 3, so x is 15. So that's 5 times 15 plus 3. 5 times 15 is 75. Plus 3 is 78. 78 degrees. And just to double check, 102 plus 78 does have 180, so they are supplementary. Might have the angles of a triangle. Are 7 less than twice the number five more than the number five more than that same number, so the number, and two times the number increased by 22. Find the angles. So once again, I'm going to draw out that triangle. I don't know which angle's bigger or whatever, so I'm just going to fill them in. So 7 less than twice the number. 7 less means you subtract 7 from something. Twice the number would be 2x. 5 more than a number. That's 5 added to something, so x plus 5. Then 2 times the number increased by 22. That'd be 2x plus 22. In a triangle, the three angles have to add up to 180 degrees. So x plus 5 plus 2x minus 7 plus 2x plus 22 have to add up to 180. Now the order that you have these here doesn't matter. They should add up to the same thing. Let's go ahead and add them up. We got x, 2x, and 2x makes 5x. 5, negative 7, and 22 is plus 20 equals 180 degrees. Now we solve for x. We'll subtract 20. Gives us 5x equals 160. And finally, we'll divide by 5. X equals 32. Now again, we have to answer the question. The question was asking us to find the angles. So we have to do each angle. This one, x plus 5, that'll be simple. We put 32 in for x. 32 plus 5 is 37 degrees. This one here, 2x plus 22, we put 32 in for x, so 2 times 32 plus 22. 2 times 32 is 64. And plus 22 is 86. That's 86 degrees. Finally, this one, 2x minus 7. Again, I put 32 in for x, so 2 times 32 minus 7. 2 times 32 is 64. And 64 minus 7 is 57 degrees. Now, I should at this point double check by adding those up, making sure they add to 180, and they do. So those are the three angles. Well, we can move on to a little bit more complex word problems. These all were set formulas, set geometric relationships, in fact. We can move on to a little bit more complex word problems that are still relatively prescribed. Might be something like Betty is paid $2 an hour more than Frank. In a week where Betty works 40 hours and Frank works 30, Betty earns, well, we didn't say Betty gets paid because we got taxes and all other stuff. We're just looking at the gross pay. Betty earns $200 more than Frank. Find each person's wage. Their hourly wage. So here we've got Betty and Frank. And what our variable actually is going to be our first variable, we're going to look at hourly wage. Which one's smaller? Well, Betty is paid $2 more. So Frank is the smaller one. We're going to let him be X. Betty is $2 more, so she is X plus 2. But now we're looking at their total pay for the week. Their week's pay. Betty worked 40 hours, so Betty will get 40 hours times her rate, X plus 2. And Frank only worked 30 hours, so 30 times X will be Frank's. The relationship here, they don't add up to something, they don't equal each other. Betty's is $200 more. So we can either look at it as Betty minus Frank equals $200, or we could look at it as Betty is equal to Frank plus 200, because Betty is $200 more than Frank. So you'd have to add to Frank to get Betty. To me, this top one is generally simpler for me to work with. So I have Betty, which is the 40 times X plus 2, plus Frank, which is the 30X. Sorry, not plus, minus Frank is the 30X, equals a difference of $200. And now we calculate it out. We solve. Start out by combining what we can on the left side here. With the parentheses, we're going to multiply by 40. So 40 times X is 40X. 40 times 2 is 80. Still have the minus 30X there. We can continue to combine. 40X and minus 30X is 10X. We still have the plus 80 equals 200. Next, we shall subtract the 80. 10X equals 12. And finally, we divide by 10. So 10X equals 120, I should say. 200 minus 80 is 120. We divide by 10, X equals 12. So X is $12, or $12 per hour. Well, X was Frank's pay, so Frank is $12 per hour. We wanted to find each person's pay there. So I have to find Betty's is 12 plus 2 is $14 per hour. So we found there each person's wage. We might find a service call is $60 plus $2 for each minute of service. How long did a call take if it costs $92? So again, here there is no set formula. We have to figure it out. It's $60 plus $2 per minute. $60 plus 2. We do times M for a minute or times X, whatever we wanted to use. That's the cost. And we know it costs $92. So again, $60 plus $2 per minute equals $90 total charge. Now we go ahead and solve. We're going to subtract the 60. So 2M equals 32. And then we'll divide by 2 to get M by itself. M equals 16. How long did it take? Well, that is what M stands for, is the number of minutes. So 16 minutes is our answer. We can run into formulas that are other formulas that are given outside of geometry. We might have in electronics. A common formula is voltage equals current times resistance. You might be given find the current, or find the resistance, I should say. If 120 volts, obviously voltage, results in a current of 4 amps. Now, if you guys know anything about electricity, you know that 4 amps is actually a rather large current. But just to keep the numbers simple, we're going to keep it at 4. So we put V is 120 volts here. I is the current, that's 4 amps, times R. We're trying to find the resistance. So here we just divide by 4, you get 30 equals R. So resistance, wouldn't expect you to know that here, but resistance is measured in ohms. That would be 30 ohms. We're going to leave this here. We're going to come back to it in 1 second here. But let's take a peek at simple interest. Formula for simple interest is the amount of interest, I, equals P times R times T, where P is the principal, that's the amount of money you start with. R is the rate, that's your percent converted into a decimal. And T is your time in years. So find the rate if an investment of $5,000 returns $40 in interest in 2 years. So we have the amount of interest. That's the $40. Put that in, equals principal. That is $5,000 we started with. R is our rate. We're looking for that. Our time in years, it's 2 years. It's just 2. So to solve this, we have to rearrange it. So the 40 doesn't change. So I don't have to rearrange, we have to combine. 5,000 times 2 is $10,000 times R. Now we divide to find R. We're solving for R. So we're going to divide by 10,000. we get 0.004 equals R. That's a rate. We said find the rate, so if you left it as that, we'd be okay with it. But realistically, we put it as a percent. You move the decimal over 2 spots, that's 0.4%. Unfortunately, that's actually a little bit high for some of your general passbook savings accounts right now. So anyway, we saw those two examples where we used formulas. We put the numbers into the formulas and we solved the equations. But if we were going to use those formulas over and over again, given the same information, for example, this one here, if we use that simple interest formula over and over again, and each time we're going to be given the principal and the time and the amount of interest, and we're going to be asked to find that rate, rather than putting it into the formula like this and having to solve an equation every time, it would be simpler if we rearrange the formula. If I took that I equals PRT, P times R times T, and I know that what I'm going to be looking for each time is that R, the rate, I would solve that formula for R. What that means is doing pretty much the same steps I did up above when I was putting numbers in, but I'm going to do it with just the letters. So first thing I'm going to do is I'm going to combine the P and the T. P times T is just PT times R. And now I'm going to get R by itself by dividing by the PT. So interest I divided by PT is just I over PT. That equals R. Now likewise, we could have took this dividing by P and then dividing by T, we would have got the same result. But now when we find, let's say that we have principal, I'm just going to put P equals, principal of $2,000 gives interest of, let's say $300 in time of 3 years. Now I can simply put that into the formula, into this expression here, and solve it. I equals 30. P is 2,000 times T is 3. That's going to give me my principal, or my rate. So in fraction bar means I have to do everything on top. There's nothing to do on top. Have to do everything on bottom. 2,000 times 3 is 6,000. Then I divide to get my rate. 3,000 divided by 6,000 is 0.05 equals R. And of course, that would be 5%. So 0.05 is a rate, or 5% is a percent. Similarly, we have that voltage formula up here, V equals IR. Same type of situation. If I was going to use that formula over and over again where I'm giving a voltage and a current and I'm going to look for a resistance, I wouldn't want to leave it as V equals IR and have to solve that equation over and over again. Instead, I would take V equals IR and I would solve for R, because I'm going to be looking for R over and over again. I realize I solve for R in both of these. Anyway, to solve this for R, I've got to get rid of the I. I is multiplying R, so I just divide by I. So V over I equals R, or R equals V over I. And now I can find values for voltage and current. Just put them in there and divide. Let's say I have 240 volts. And my current equals 4 amps. All I have to do, put 240 over 4 equals R, and I can divide that out. 240 divided by 4 is 60 ohms. I've got a resistance of 60 ohms. Well, let's look at some slightly more difficult formulas here. The formula for converting degrees Celsius to degrees Fahrenheit. is this. F is equal to 9/5 times your degrees Celsius plus 32. So let's say we're going to find degrees Celsius if the temperature is 98.6 degrees Fahrenheit. Of course, that goes in where F is, 98.6. Well, to solve this, we're solving for C, we're going to have to subtract 32. That's 66.6 equals 9/5 C. And then we would divide by the 9/5. Dividing by 9/5, remember, is the same as multiplying by 5/9. So I'm going to take 66.6 times 5 divided by 9. That's multiplying by 5/9. I get 37. So the Celsius temperature is 37 degrees. That's 37 degrees Celsius. So here it was just a single time I wanted to take that one temperature of 98.6 Fahrenheit and convert it to Celsius. But if I was doing that over and over again, if I was converting Fahrenheit temperatures to Celsius temperatures, I would want to rearrange this formula so that it was C equals some formula. If I wanted to solve for C, I'll take that formula. F equals 9/5 C plus 32. And I have to get C by itself. C is multiplied by 9/5, and then 32 is added to it. So to solve it, I'm going to reverse that. I'm going to subtract the 32. That's gone. Over here, F minus 32 is just F minus 32. Now C is multiplied by 9/5, so I'm going to divide by 9/5. Well, instead of dividing by 9/5, I'm going to multiply by the reciprocal. I'm going to multiply by 5/9. That's the reciprocal of 9/5. So on the right side, I'm left with just C. Over here, multiplying, well, the subtraction has to happen first, so I need parentheses. That's F minus 32 times 5/9. So that is the conversion formula. Degrees Celsius is our Fahrenheit temperature minus 32 times 5/9. So we can use that over and over again. One more example of these, we might have a power formula. Power of an electrical circuit is equal to the voltage squared divided by the resistance. Let's solve for V. So we have V by itself. V has been squared, and then that was divided by R. So to solve it, I reverse that. I'm going to multiply by R. So the R cancels out over here. P times R is just PR. All that's left on the right side is V squared. To get rid of the squared, we have to square root. So the square root and the squared cancel out, leaving me with V over there. It's the square root of P times R. So we could express it as V equals the square root of P times R. Well, we might take that same formula, P equals V squared over R, and we might solve for R. That's a little tricky. R is on the bottom of a fraction. So we either have to get it out from underneath the bottom, or we can do it like this. We can turn it into a proportion like that. So we got P over 1 equals V squared over R. Remember, to solve for it, if we treat R as our missing piece of the proportion, to solve for it, you cross multiply and divide. So R is equal to 1 times V squared is just V squared divided by P. So R is equal to V squared over P. Another way we could have handled it, if you don't like to do that proportion, is since what we're solving for is on the bottom of a fraction, we have to get it out of there. So you could have just multiplied by it, multiplied by R. So R is gone. So over here we got P times R is PR equals V squared. And we still have to get R by itself. It's P times R, so we get rid of the P. So R equals V squared over P. So the same result we got before. A couple of different ways of approaching. There are, I'm sure, other ways you could approach that. Still get the same result. So we have looked at solving equations, problem solving, writing equations from them. Hopefully that clears that, is enough for that topic. If you have any questions, please let me know, and I'll get back to you as soon as I can. Otherwise, have a great day. Remember, this would correlate with homework 2B, so you should be started on that. Okay, well, see you all tomorrow.